Hello, this video will walk you through monitoring RabbitMQ using the RabbitMQ Zen pack for Zenoss. You can find documentation here that I'm looking at github.com/Zenos/zenpacks.zenos.RabbitMQ. This documentation will walk you through the same thing I'm going to go through in this video in terms of setup and what you get out of it, but this can be a better format just so you don't have to do it yourself. So I've already installed the Zen pack via one of these methods. It doesn't really matter which one you use, you get the same functionality. So what I'm going to do is go over to my Zenoss instance in this tab here and navigate into a device that happens to be running RabbitMQ. So I haven't set this thing up yet. What I want to do first is I need to set up SSH access into this server, because the way the Zen pack works is to remotely execute the RabbitMQ CTL command and its various subcommands over SSH. So the way you do that in Zenoss is the same way you do any kind of SSH monitoring. We'll go into the device's configuration properties. You could do this for an entire device class, so you don't have to do it on a per server basis, but I'm just going to do it for this particular server. Then in these configuration properties, I'm just going to search for the command category to get to the properties that I'm most interested in here. And the properties you want to use are, first of all, the Z command username. And this is going to have to be a user on your RabbitMQ server that has permission to run the RabbitMQ CTL command. In my case, I'm going to kind of go the easy way and just use root. Then you can also set the Z command password. Now, depending on if you want to use public key authentication or not, with public key authentication, this will actually be the passphrase for the key if you need one, or blank if you don't. Or if you don't use public key authentication, this is the actual password for this user. And here's where you specify the private portion of the key path. So those are actually set up properly for this server right now. So what I'm going to do is the next part of the setup. And again, this can be done on a per device basis like I'm doing here, or for an entire device class. So you can just discover Rabbit information for all the devices in a particular class. So in this modeler plugin right now, we have a bunch of modeler plugins selected. Looks like I actually have RabbitMQ selected. You might not after you install the Zen pack. Right? You may have something that looks more like this. So just to keep this simple, what I'm going to do is I'm going to remove all the standard modeler plugins and just enable the Zenoss.ssh.RabbitMQ modeler plugin. Save that. Then I'm going to do an immediate remodel of this device by going to this gear menu down here, choosing model device. This is going to run all the modeler plugins that I have configured for it to discover what's available to be monitored on the device. And we can start seeing some Rabbit information here, right? We're trying RabbitMQ CTL on the IP address of this device. It says it found a node called Rabbit at Maverick. The host name of the system is Maverick, so that's the default node. Found a vhost, the default vhost / with 12 exchanges, 19 queues. Found another vhost with 6 exchanges and no queues. Right, so exactly what we would expect to find there. So I'll close that window, and we'll see more information now. We see that the RabbitMQ information has been discovered on this particular device. So first things first, we'll kind of start at the bottom, and we found that one node, the Rabbit at Maverick. And I previously had this discovered in here, so I have some historical performance metrics just so you can get an idea what those look like. But on a per node basis, what we're looking at is total connections and total channels that are open on those connections. All right, so we see that I had 12 open with my application for a while there, then I shut that application off, so all my connections dropped to 0. We can see what the send queue is sort of globally for the entire node. That's been 0 all along. And then we can see the throughput in terms of messages, again globally for the whole node. We had a little spike up there, but mostly it's just hovering down here at a lower value. And finally we can see throughput in terms of bytes sent and received. And we can see the channels and messages, right? So how many consumers and messages, how many consumers are there currently? And in the past, how many messages are unacknowledged or uncommitted. So that's all high-level information on per node basis. We could go in here and we can see all of the, say, all the vhosts, all of the related exchanges, all of the related queues for this particular node. Or we can use this navigation on the left to say, okay, here are all of the vhosts, here are the node they're on, here are how many exchanges and queues they have, here are their related exchanges and queues if we want to get the actual details. So let's go ahead and go into something kind of interesting here in terms of a queue. Right? We have performance metrics being collected against each individual queue as well. Right? So let's see if we can find a more interesting queue in here somewhere. I think on this, yeah, this compute.maverick, this is an OpenStack Nova server. So we can see here, again, right, I had sort of no messages sitting in the queue, which is the state I really want to be in all of the time. And then I shut down some of my daemons, so I had a spike in the queue up to just one message sitting there for a while because nothing was consuming it. I can see the per queue memory usage. I can see the in the per queue consumers. And you can see there's actually a threshold defined on the per queue messages, right? I think one of the things that I most often want a threshold on an individual queue is how many messages are sitting there in that queue waiting to be consumed, because this can be a sign that you have a bottleneck somewhere, you have a backup in a queue. So what you can do here is on these individual queues, you can go and you can set an individual threshold. Now there's a default threshold on every queue for 1 million messages, but that's kind of absurd. Hopefully you never get a queue with that many messages in it. So if I want to say I never want to see, let's say, more than one message sitting in this queue, I'll put 1 here as the maximum. Be good to go. Go back to the graphs, right? And I can see my threshold line there. Or if I find a queue that maybe had some more items in it, maybe my scheduler queue had 13 messages in it for a while there, I could do the same thing and add an individual threshold to that. And I'll just say this as a 10 threshold. Right, so now what happens is if I ever get into this condition where I have more messages sitting in my queue than this threshold line, I'm going to get an event about it. And that is RabbitMQ monitoring with Zenoss. Thanks for watching. Go ahead and fork the repository on GitHub if you have any changes you want to submit. I'll be glad to pull them in. Thank you.